So one thing that we're going to talk about in tonight's lesson is using some more of the angle identities that you guys have on your reference sheet. So if you want to get that out, go for it. And this video is going to be about our double angle identities. And think of it, double means you have two things. So this is when I have a double or a two in there. All right, so first let's put a title on this, double. Okay, so double angle identities. And what I'm talking about is we have sine 2 theta. All right, this is a double because this is not just the sine of theta, it's 2 thetas. Okay, and this, it's on your reference sheet, is equal to 2 times sine theta times the cosine of theta. I think your reference sheet uses A's and B's. Okay. And there's also the cosine of 2 theta. All right, there are 3 different options for cosine 2 theta. All right, the first one is cosine squared theta minus sine squared theta. All right, don't confuse this with our Pythagorean identity. This has a minus sign. Or we could also have this equal to 2 times cosine squared theta minus 1. Or there's another one. This could be equal to 1 minus 2 sine squared theta. Okay, notice there is also a double angle identity for tangent 2 theta, but you can see it on your sheet, but we're actually going to prove it tomorrow. So we're not going to use that in this video. We're going to use that tomorrow. But actually, since I want to prove tangent tomorrow, I kind of want to go through the proof for the tangent identity. All right, and don't freak out when you hear the word proof, because it's really not that bad. All right, so let's do a proof. And we're going to prove this right here, that the sine of 2 theta is equal to 2 sine theta cosine theta. So let's start with the left side, all right? Let's start with the sine of 2 theta. I need to somehow find different ways to write this so it eventually looks like the right-hand side. All right, and thinking of this, remember all of these trig identities that we're using kind of build upon each other. So we kind of always want to look to see how we can use them together. Okay, and we can right now because instead of writing this as sine 2 theta, isn't 2 theta the same thing as theta plus theta? So I can write this as the sine of theta plus theta. All right, if you want to put this in parentheses, you can. So the sine of 2 thetas is the same thing as the sine of theta plus theta. Okay? And then this is perfect because we have an identity already, or a formula already, for the sum inside of sine, the sine of the sum of 2 angles. All right, so that's going to be sine, cosine, cosine, sine. It looks a little silly because we're used to doing it with 2 different things, but that still works. And just for funsies, I'll leave this as sine theta, cosine theta, and that's what I'm going to do for this right part. I'm just going to switch these so it looks like the first term. And we can do that because multiplication is commutative. And then, okay, look, I've got 1 sine theta cosine theta plus another sine theta cosine theta. So you're just combining those because they're like terms, and you get 2 sine theta cosine theta, which is what we wanted. Okay? 4-line proof, not bad. We can also do the proof for cosine. Now, there are 3 different double angle identities for cosine. I'm going to do the first one, and we're going to work on the second 2 tomorrow. But I'll prove the first one. So let's do the proof for cosine 2 theta. And really, this is going to start the exact same way that I did the proof for the sine. Okay, because I can rewrite 2 theta as theta plus theta. And we have a formula for the sum of the cosine of a sum, sorry. And so this is going to be cosine, sine, sine, sine. Remember that the sign in the middle changes? And cosine times cosine, that's just cosine squared. And sine times sine, that's just sine squared. And boom, baby, that's what I wanted. Okay? 3-line proof, even easier. Okay? So like I said, we are going to prove these 2 in class tomorrow, along with the tangent identity. All right, and I promise you they're pretty easy. But the big thing is that we need to know how to actually use these. So we're just going to do one example, and then we're done. Okay? So if the cosine of A is equal to negative 5 over 13, and angle A is in quadrant 2, we are going to find, and then I'm going to write this down here. We're going to find the sine of 2A, and then we are going to find the cosine of 2A. Okay, why did I write those all the way down there? Because just like it's been for all of these other angle identities, I'm probably going to have to use my Pythagorean identities to figure some stuff out. Okay, because if I look for the sine of 2A, that is going to be equal to 2 times the sine of A times the cosine of A. Okay, we just proved that, and it's on your reference sheet. So anytime you're asked for the sine of 2A, look at your reference sheet, that's what you need. Okay, I know the cosine of A to plug in here, but I still need the sine of A. So we're going to have to use our Pythagorean identity. All right, and that would be, oops, what did I do? Mixing up my colors. So that's going to be sine squared A plus cosine squared A is equal to 1. All right, I need to find sine of A. And you should show all of this work. I know that it's becoming a little redundant. 13 squared becomes 69, I think. Let me check that out on my calculator. Yep. And then we're going to do 1 minus that stuff. So I get that sine squared A is equal to 144 over 169. Take the square root of both sides. You get plus or minus 12/13. I'm in quadrant 2. Signs are positive in quadrant 2 because that's the y values. So I really want just the positive 12 over 13. So now I'm good. Now I can plug in. And this is going to give me 12 over 13 times negative 5 over 13. And now you can just go ahead and multiply. Now remember, this 2 is really like a 2 over 1. Or you can just plug this in your calculator. I would be careful with your parentheses if you do. Okay, but if I go straight across the top, I've got 2 times 12, 2 times 12 times negative 5. That's going to give me negative 120. And then I've got 13 times 13, that's 169. And let's see, 120 divided by 169, does that simplify? Nope. So this right here is your final answer. That is what the sine of 2A is equal to. Now let's come over here. I want to find the cosine of 2A. Boop. Now, even though we have 3 formulas to pick from, in this case, it really doesn't matter. Okay, because from all of this work that we just did, we know the sine of A, we know the cosine of A. So it would be reasonable to plug into either one of these. I'm just going to plug into the first one because it's the first one. So this is cosine squared A minus sine squared A. And I just found out that the sine of A is equal to 12/13. And in the original problem, it told me that the cosine of A was negative 5/13. Okay. So negative 5/13 squared, that's going to give me 25 over 169. Minus, I'm going to get 144 over 169. 25 minus 144 gives me negative 119 over 169. These already have common denominators, which is awesome. And let's see if that reduces to anything. It does not. So this is your final answer. Okay? Say, for instance, you weren't me. Well, you're not. And you wanted to use a different one. So you did not want to use sine squared A or cosine squared A minus sine squared A. That's totally cool. Okay, so let's come down here. Let's see if we get the same answer if we use the second possibility. So 2 cosine squared A minus 1. Okay, if we plug into that, that's going to be 2 times negative 5/13 squared minus 1. So that's going to be 2 times 25 over 169 minus 1. 2 times 25 over 169 is going to give you 50 over 169. Still have that minus 1. And when you do that, you get negative 119 over 169. So if you didn't believe me before, you will get the same thing because these are equivalent. And that is it. I'm done. Be prepared to prove the other 2 cosine identities and the trig identity. All right, try and do that for homework because I'm going to put one of you on the spot to try and do it in class.